Okay, here's the key for the test review for Monday, piecewise functions and absolute value. So the first type of questions, we're going to use the table, the parent function table for absolute value of x. -2, -1, 0, 1, 2. Absolute value of -2 is 2, 1, 0, 1, 2. So we're going to refer to that table through these for these problems, especially for the table, this column right here. So describe the transformation. So the very first one, we have a 5 in front. That's going to be a vertical stretch of 5. The -1 on the inside is going to be a right 1 movement. The -3 on the outside is a down 3. Okay, so the new table, which is basically just modifying this parent function, you want to ask yourself, what do each of these do? What variable do each of these transformations affect? Okay, anything on the outside is going to affect the y's. So the 5 and the -3 are going to affect the y's. Let's do a vertical stretch of 5 first, okay? Because that's kind of your PEMDAS. You want to multiply by 5 before we subtract 3. So what we're going to do is we're going to multiply each y value by 5 and then subtract 3 or move it down 3. I'm going to do those together in one step. So what we're going to do is multiply by 5, -3 to each y. 2 times 5 is 10, -3 is 7. 1 times 5 is 5, -3 is 2. 0 times 5, 0. -3, -3. 1 times 5, 5, -3, 2, and then 7. Now the right 3 movement is going to be just the x. So we're going to add 1 to each x value. So if you add 1 to each x value, that's going to be -1, then 0, then 1, then 2, then 3. So there's a table for that one. Domain, absolute value is always -infinity to infinity. The range, parent function range, so the parent function is 0 to infinity, and it looks like this. So think back to the transformations that we had for this question. The transformations we had, vertical stretch of 5, that's not going to affect the range. Down, right 1, that's not going to affect the range. Down 3 will. So that's going to move our parent function down 3, so it should be -3 to infinity now. Okay, the next one, negative in front is reflection across the x. +4 is up 4. Reflection across the x is going to affect the y values. Up 4 is also going to affect the y values. Let's do the reflection across the x first. So nothing's going to affect the x. So I'm just going to copy the x here, -2, -1, 0, 1, 2. The y value, reflection across the x is going to make it negative, then move it up 4. So we're going to take this 2, make it negative, so -2, then add 4 to it, so 2. Make 1 negative, -1, add 4, 3. And you can do that for the next couple, and you'll be left with that. Domain, -infinity to infinity. Now range. Okay, so both of these affected our y, so our range is going to be different than 0 to infinity. So what we did is we reflected across the x and moved it up 4 in that order. So our graph is going to look like this. It's going down, and not only is it going down, but it's shifted up 4 units. So this one's going to be -infinity because it's going down, and the furthest it goes is up to +4 because we moved it up 4. Next one, left 3, down 1. This one's pretty straightforward. The top one's going to affect the x, bottom's going to affect the y, so I'm just going to subtract 3 from all my x values. So that would be -5, -4, -3, -2, -1. And down 1, I'm just going to subtract 1 from all my y values. So that would be 1, 0, -1, 0, and then 1. Domain is the same. Range, we didn't reflect it. Left doesn't affect it, just the down 1 is going to affect this, so -1 to infinity. Last one, we have 3 transformations. We have a reflection across the y-axis, because the negative on the inside. The 2 is a horizontal compression of 1/2, and then -5 is down 5. Reflection. Okay, so reflection across y is going to affect the x values. Okay, and horizontal compression is going to affect the x values, and then the down 5 is going to affect the y values. So I'm going to do the down 5 first. The y values. Subtract 5 from my original parent function table. So that's going to be 2 minus 5